Today we're going to talk about genetic recombination. Did you have a pet when you were growing up? For their first pets, a lot of people tend to get hamsters. But did you ever wonder why some hamsters look different than others, even when they have the same parents? Well, I can show you why. If an organism has 3 traits, the varieties of those traits could recombine to produce gametes that could result in progeny with all different combinations of outward appearances. This can be achieved through genetic recombination. These traits, hair color, hair length, and whisker type, are 3 linked loci on a chromosome, each with 2 alleles. Big B for beige hair, little b for white, big S for short hair, little s for long, big C for curly whiskers, little c for straight. To begin, we need a heterozygous individual. This individual can be produced by crossing 2 parents who are homozygous for all 3 loci. So we're going to cross the parent with the genotype little b, big S, little c, with the parent with the genotype big B, little s, big C, big C. Now that we have our heterozygous individual, we know that the distance between B and S is 14 centimorgans and the distance between S and C is 19 centimorgans. Our coefficient of coincidence is 1.503. This individual can produce 8 different gamete types. This can be achieved by having no crossover events or recombination, double crossover events, which is pretty rare, or lastly, single crossover events at positions 1 or 2. Let's start with no crossovers. If there are no crossovers, we end up with gamete types white short hair with straight whiskers and beige long hair with curly whiskers. In the event of a double crossover, we'd end up with gamete types beige short hair with curly whiskers and white long hair with straight whiskers. In a single crossover at position 1, we would get gamete types beige short hair with straight whiskers and white long hair with curly whiskers. And in a single crossover at position 2, we'd get gamete types white short hair with curly whiskers and beige long hair with straight whiskers. Now, if we want to look at the probability of each crossover event occurring, we'd have to do a few calculations. To find the probability of a double crossover, we need to multiply the distances of region 1 and 2, which we assume is approximately the same as the recombination frequency, by the coefficient of coincidence. The probability of an SCO1 would be region 1 minus the DCO event. The probability of an SCO2 would be region 2 minus the DCO event. And the probability of no crossovers would be 1 minus any crossover event. If we wanted to find the probability of a specific gamete type, we'd do the same calculation as before, but we'd multiply it by 1/2. This is because every crossover group yields 2 gamete type results, but we're only looking for 1. So if we wanted to find the probability of getting big B, big S, little c, I'd first determine what kind of event would have to happen. Once I see that it is a SCO1 event, I subtract the DCO event from the recombination frequency, same as before, but then I multiply it by 1/2. If I wanted to find the probability of little b, little s, little c, once I see that results from a DCO event, I'd multiply the recombination frequencies of region 1 and 2 and the coefficient of coincidence. But to finish it off, I'd multiply it by 1/2. I think that's it for today, but here are my sources and thank you so much for watching.